Right now, 3I Atlas is racing past Mars, about 0.19 astronomical units away, and we're catching it mid-sprint. It's only the third confirmed interstellar visitor we've ever seen, and this is our narrowest best look. Here's the problem. From Earth, the Sun is squarely in the way. Our telescopes are effectively blind during this geometry, so the only clear angles belong to the orbiters around Mars. That means a handful of spacecraft have to do the work of an entire planet, snapping rapid images, sniffing the gas around the comet, and hunting for any sudden changes, while juggling tight data windows and limited power. If anything unusual happens now, fragmentation, a chemistry shift, a brief outburst, we either catch it from Mars or we miss it. And it's already behaving in ways that don't neatly fit the Comet playbook. Whether this turns into a quiet lesson in cosmic chemistry or a chart-rewriting surprise depends on what those Martian orbiters see in the next hours. And that's just where the story begins. How rare is this, really? Before 2017, interstellar objects were the stuff of textbooks and probability estimates. Then Oumuamua arrived, followed by the dust-rich comet 2I Borisov. Now it's 3I Atlas, only the third confirmed interstellar visitor we've ever tracked in detail. Its orbit is unambiguously hyperbolic, so there's no return trip, no second chance. Hubble and other facilities suggest a nucleus somewhere between a few hundred meters and a few kilometers across. It's an opportunity. A brief, lopsided one where Mars, not Earth, gets the best seat. As 3I Atlas cuts inward, the Sun sits between Earth and the comet, drowning our detectors in glare. Mars, offset in its orbit, keeps a cleaner line of sight. That's why a small fleet, ESA's Mars Express and ExoMars Trace Gas Orbiter plus NASA assets, stacked special observation plans for this narrow window. The goals are surgical. Track the light curve for sudden changes, sniff out the fingerprint gases in the coma, and watch for any fragmenting or jets as sunlight turns up the heat. Cadence will be high, telemetry windows tight, trade-offs relentless. When you only have a handful of eyes, you choreograph every minute. And the main thing they're chasing is chemistry, because that's where 3I Atlas refuses to act average. So what exactly is off about the chemistry? Most comets warm up and shout water. Not this one, not yet. JWST and NASA's SphereX mission report a coma dominated by carbon dioxide, with a CO2 to water ratio near 8:1, among the highest ever recorded in a comet. That's a big clue. Maybe 3I formed far from its home star where CO2 ice was abundant. Or maybe water is buried under a crusty, insulating layer that delays the usual H2O fireworks. Either way, the numbers say unusual origin story. And the spectrum doesn't stop at CO2. There are signatures of water, CO, OCS, and dust, the kind of mixture that lets modelers probe where these ices condensed and how they're being released. This is why a Mars angle view matters. A continuous high-cadence watch can tell us if the chemistry evolves as the heating ramps. And then there's a metal in the mix that raises eyebrows. The nickel puzzle. Observations from the Very Large Telescope picked up neutral nickel lines in the coma, while iron looked faint or absent at similar distances. That's not how many solar system comets behave. Nickel and iron often track together, both liberated from heated dust grains. One natural idea is that certain nickel-bearing compounds release more readily at these temperatures than comparable iron species. Or we're simply catching a time slice. Iron may wake up closer in, which some datasets suggest begins to happen as 3I Atlas warms. None of this screams artificial. It does force better physics. How refractory metals ride off dust, how sunlight sorts grains, and how a non-solar system past might bake in different mineral mixes. The safety question is easy. There's no danger here. Distances to Mars and Earth remain comfortable. The only close call is with our schedules and bandwidth. The practical stakes are scientific. How much we can learn before the geometry changes again. What comes next? After Mars, attention shifts to the weeks around perihelion and to longer-range follow-ups as 3I Atlas heads outward. Expect new attempts to tighten size and mass, to watch whether water outgassing ramps and narrows that wild CO2 ratio, and to see if the nickel-iron story changes with heating. As geometry improves, JWST, Hubble, and ground giants will rejoin, and Jupiter route spacecraft may offer side looks. Best case outcome? A clean, time-resolved chemical and dynamical record of a comet built under alien skies. If it turns out to be wonderfully natural but fundamentally different, that might be the most exciting result of all. Because it means the galaxy makes comets in more ways than we thought. One fleeting pass, a handful of hours where Mars becomes our stand-in observatory, a chemistry lesson written in infrared, and a metal signature that refuses to play by the familiar rules. Whether 3I Atlas becomes the benchmark for weird but natural, or opens a door to something we haven't modeled yet, it's already doing the most valuable thing an interstellar visitor can do, forcing us to measure better and claim less. So what do you believe? Is 3I Atlas simply a boring anomaly, or is there more to the story? Share your theories in the comments below. And until next time, stay curious.